Good afternoon and welcome to Webinar Wednesday. Today we are joined by Joe Stockman, Director of Product Experience at FSI, and Justin Ryan, Product Owner, CMS Analytics at Enstoa. And they will be discussing smart tools for smart operations, AI and technology in HTM and HFM. Now, Webinar Wednesday would like to thank our sponsor, FSI, a healthcare CMS EAM provider. So to learn more about FSI's platform, please visit fsiservices.com. Now, just a reminder to save the date for our fall MD Expo, which will be held at the Renaissance Dallas Addison Hotel in Dallas, Texas, and that will be November the 10th to the 12th. So please join us for 3 days of education, networking, and the latest advances in medical technology products and services. For more information and registration details, please visit mdexposhow.com. Okay, today's webinar, as usual, is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit, and you'll be able to download the certificate directly from your computer once you submitted the survey. Now, if you have any questions, you can reach us at webinar@mdpublishing.com. Let's kick off today's webinar by giving away a Swissforce Meister multi-tool. So using the questions feature on your dashboard, let me know the answer to the following trivia question. August is peach month. Which state is the largest producer of peaches and also known as the peach state? I'll reveal the answer and our winner at the end of the webinar. We'll be wrapping up today's presentation with a live Q&A, so please submit your questions anytime using the questions feature on the webinar dashboard. As I mentioned earlier, our presenters today are Joe and Dustin. So Joe and Justin, you may begin whenever you're ready.
All right, thank you. So welcome everybody, thanks for joining us. Today we're going to go through the brief introductions of Justin and I. Then we're going to look at the current landscape of technology, look at a couple advanced use cases, and then we're going to talk about how to set up your data in your system for use of technology. You know, it's just not going to, bad data in, you probably heard it before, garbage in, garbage out. So we're going to show you what it takes to set it up so you can start taking better advantage of some of these insights. We'll talk about the future and where things are going, and then we'll wrap up with Q&A. So a little bit about myself. I'm Joe Stockman. I'm the Director of Product Experience here at FSI. I've been with FSI 22 years and have just about 30 years of healthcare CMMS experience. And my role here at FSI is I work with customers to help them solve the problems and improve, our CMMS, with technology based on some of their hurdles and their struggles throughout the day. And Justin, if you want to give yourself an introduction.
Yes, thank you. My name is Justin Ryan, and I've been with Enstoa. We're a company that partners with FSI to kind of leverage a lot of the data that is produced by FSI CMMS. And my role for the last several years has been kind of working with different healthcare systems for doing things like business intelligence work. So everything from kind of data engineering and kind of figuring out how to capture whatever data might be going into systems, and then figuring out how to kind of integrate all that data and then how to use that to produce results and then make decisions based on those results. So thanks, Joe.
You're welcome. As you can see, those are our most recent photos. So that's so a little bit about FSI. We call ourselves healthcare's leading CMMS, and we're a CMMS built for healthcare professionals. And many of us that work here at FSI, we're healthcare service support professionals, whether it's in the facility space or the HTM or biomed space or clinical engineering space. I know they have a bunch of different names, facilities engineering, maintenance, lots of different terms for the different departments. But our group here at FSI has people from all of those disciplines. We build in from the ground up, regulatory standards with Joint Commission, DNV. We also support other authorities having jurisdiction as well, like ACHC and CIHQ and any state or local fire department jurisdictions. We have a customizable setup for ensuring compliance. And as I see, and some little things about FSI, we have a high customer retention rate. Once people switch over to our CMMS, we have about a 99% customer retention, and over 1,100 hospital departments using our CMMS. And we have monthly support and educational webinars. We're constantly talking about our software and how it works. And, for new users, new onboarding, it's very educational and useful for them to join these webinars. We also have an annual user conference free for all customers. This year it's in Denver, I think in October. And we also have our FSI neighborhood. We're a Pittsburgh-based company, so that was sort of based on the Mr. Rogers neighborhood theme. And it's a 24/7 learning community where customers can interact with each other. So we're constantly talking to customers and working with customers to find out what their technical hurdles might be, or just day-to-day improvements that we could take technology and leverage those for in the software. So, the current landscape, how does advanced technology in the HTM, that's the healthcare technology management, and HFM, healthcare facilities management, and basically, these tools are empowering teams more than ever, with simplicity and mobile apps, with other things that we'll talk about later, such as integrations and AI, obviously, since that was in the title. We're really, reducing time, and that's really the best benefit. That's probably where most of your dollars are going in your department, is towards labor and time for fixing these things and digging into this and trying to find the right information and find the right part. So how do we use technology to save that time? And then, that's true for staff in the field and the staff in the office. How can you make yourself work faster? How can you make reporting faster? And how can you have everything more accurate across all operations? So some advanced use cases for technology. AI, that's the elephant in the room that we're going to talk about. And, specifically around compliance. Compliance is, something that healthcare service professionals have to show and have to report on. And, one of the benefits of AI is it really does excel at digesting complicated information. So if you feed it, a bunch of information, a bunch of data, and say, summarize this for me, if you've used some of the chat GPTs or co-pilots or some of the other AI things out there, you can see that if you, get a long email and ask it to summarize it for you, it does a really good job at digesting that and turning it into a common language. And there's a lot of data, related to compliance, related to the work you're doing to prove compliance, relating to the work you're showing to follow up on compliance, that AI is the perfect use case for this. And that could be, when an inspector, a regulatory inspector is on site, it could be an on-demand request, like show me all my high-risk medical equipment compliance for the past 6 months. Or show me all my generator inspections for the past 3 years. Those are some things you could do on demand, or continuous monitoring, where as soon as something is flagged as out of compliance, it lets you know those things. So it could really help, again, from running reports and sifting through data manually. Can AI be one of the tools that's useful for that? And next is, integrations. It's a technology that you really, hospitals have many systems, from building automation systems, medical device security systems, lots of different systems in place, monitoring from parts ordering. So how can you make all these systems talk to each other? And that's really what integrations is all about. And can AI help expedite performing some of those integrations? There's a lot of manual mapping, or, hey, this asset's called something in one system and called something different in another system. So how do you align those? So there's a lot of work to just make integrations work. And can we use technology to make that easier as well? And then finally, or maybe at the start, this is where you start, maybe they're in a reverse order, but data capture. How can you use technology to get that inventory? It's a requirement by the Centers for Medicare and Medicaid Services, CMS, the regulatory agency, which is what Joint Commission, DNV, all the other authorities having jurisdiction, at least the national ones, adhere to. But how can you use technology to help you with that data capture stuff? So what we're going to talk about next is, how do you build a foundation for AI? And you could potentially use AI to help you do that. So we have these 7 pillars defined. Pillar 1 is structural characterization. Pillar 2, space management. Then we go into asset inventory, data preparation, asset management, and then finally asset maintenance and regulatory compliance. That's sort of what ties it in together. And they're not in any particular order, although following the order does make sense for sort of building your system from the ground up. So we'll start with Pillar 1 and structure characterization. I'll pass it over to Justin.
Thank you, Joe. And to kind of just elaborate on that for just a second, the goal of this is to, like Joe mentioned earlier, there's always the paradigm of bad data in, bad data out, which obviously leads to environments where, advanced use cases like AI aren't going to work. But even beyond the kind of bad data in, bad data out paradigm, there's, these applications of integrations where things need to be connected in order to get value out of this. Like obviously everyone could, go find a manual online to figure out how to inspect an infusion pump and then copy and paste all of that data into an AI tool and then ask it to summarize, find relevant procedures, et cetera, but that's tedious. It doesn't necessarily save you the time or give you the productivity back that, you might otherwise get. And so these pillars help get you into a space where now you can leverage your space data, you can leverage your asset data, and then you can start to build things on top of it. So they provide the kind of foundation for the building that is going to be kind of an advanced technical system. And so the first of these is structure characterization. So a big part of managing healthcare facilities is obviously managing the spaces that you're in, understanding kind of where the systems in that space, where they're located, what rooms and what spaces those systems serve, et cetera, et cetera. And so the kind of first step to this, and something that, that some of these AI models and some of these kind of advanced like technical robotics and LiDAR scanning and things like that can help with, is just establishing what we typically will call something like a digital twin of a space. And so that's where you might scan your facility, you might have panoramas, you might have, these kind of walkable environments where almost in kind of virtual reality, you can walk through your space, and without having to visit a room, you can see, these are the assets in that room. This is the geometry of that room. This is how much space is there. This is how much space is going to be, removed or added from any kind of construction or renovations. And the goals of these are, one, to give you that data, and to also make sure that it's lightweight and it's something that you can maintain, because it doesn't really matter if you create, a digital twin of your facility, if it's going to be difficult to maintain, it's going to be out of date in 2 months when you then, renovate a room or a wing. The way that we do these currently on the Enstoa side is we'll, walk robots through. We have these kind of 3D LiDAR scanners that'll give you kind of down to quarter-inch resolution of a building. We make these point clouds, and then we kind of process all of that, and you end up with these kind of building information management system models that allow you to then use that data. You now have turned a physical space into electronic data that you can use for something else.
Yeah, think of it kind of like Google Maps, if you've ever done the Google Maps, but for your building. So instead of a car driving through your building, that would not be good, but a person walking around doing these scans. And then you get the visual image. If you ever looked at Google Maps or Street View, where you can look at fronts of structures and buildings and stuff like that, it's the same type of technology, but a lot more detailed. Like as Justin said, it gets down to the quarter-inch, which is what most manual floor plan are adhered to, is that quarter-inch standard. So FSI started doing floor plans 20 plus years ago. We did them manually. I actually carried a tape measure and a laser measure and went around and built some of these floor plans manually. And I wish this existed 20 years ago. It would have saved me lots of time and doing these types of things. But again, great use of technology for building out these spaces. So, all right, let's move on to Pillar 2. And Justin, back to you.
And this flows directly from kind of Pillar 1. So once you have that data, there's the kind of element of then using it. So we've kind of done the step now of taking a physical space and transforming it into kind of a, into the electronic world where we can then do things with it. And so this is where things like FSI Space Manager tool, or Enstoa has a Space Manager tool of their own. That's where these come into play, where you can now take that space and you can say, okay, this room, that's an object. This room is being utilized by these groups. It's served by this system. It's, whatever you might be doing with it. And it allows you to then kind of take that and you can, we'll get on to integrations here in just a little bit, but now you start to have this model where I know what space I have, I know how it's being used, I know how it might change, I know the dimensions of it, and then I can start to kind of plug that into other systems like, for example, FSI CMS, and I can leverage that data. And so the goal is here to, just make sure that the inventory is accurate, but also to just make sure that you can do something with that data. So beyond just knowing that, I have this point cloud like cube of a room in this area, I have something that represents, these assets can be tied to this room. These HVAC systems are serving this room. If temperature readings in this room are low, then I can check these systems to kind of verify what, or diagnose where that issue may be. And again, the goal with these is to set these up in such a way that not only are they accurate, but they're, again, easy to maintain. That's so critical through these things. And we'll kind of, mention it a little bit later about how, AI tools and other kind of AI assisted softwares can kind of make that a little bit easier to maintain. Because again, all of that utilization and occupancy and, other kind of data is pointless if 2 months from now it's not up to date.
No, thanks. And those standards that Justin's referring to, ASHE, the American Society for Healthcare Engineers, actually worked with the FGI and a number of other organizations, that's the Facility Guidelines Institute, to define those types of spaces and what their utilization is. So if you're looking at, classifying a room, look to the ASHE website or your facilities departments to gain access to that. And FSI and Enstoa were both on that committee to help define some of those standards. We define standards for asset categories and for space designations to really try to help the industry align. So, not only can you compare stuff within your own organization, but you can compare outside of your organization. If everybody's talking the same language, it's really helpful to adhere to those same standards that other hospitals are adhering to. So you'll see a lot of hospitals starting to adopt those standards. I think they were published in 2021, I think was the first publication of those standards. And then also think about risk. If you're doing your risk assessments, having access to this data of where that equipment might serve or where that, that particular device is located, does that have a higher risk if it's in an ICU versus another part of the hospital? So think about those things as well. So again, starting with this data really helps you look at, and as we get through the rest of the pillars in the future, setting the stage. This is all, setting the stage for how you take advantage of this technology later. So, notice there's 2 pillars just related to space and where things are located. So.
And I think that'll flow in, back to your point about things, not being in a particular order. I think that'll flow nicely into the next slide, where when you're talking about assets that serve these spaces, you've got to know what assets you have. And I'll let you kind of take that, Joe. Yeah,
on the asset inventory side, this is the Centers for Medicare and Medicaid Services requirement where you have to have, an accurate asset inventory of your medical devices, of your facilities equipment, of your utilities. All those things have to be in your system, in your CMMS or somewhere. I guess it doesn't say you have to put them in your CMMS, but that's where most people put them. And that's where I would recommend putting them as well. You want to have one place for everything that's in the same location so you're not struggling to find that information. But the main thing you want to do is capture that accurate information. Can you do that with technology? We'll talk a little bit about that later and how that could work. But you want to make sure you know where those assets are located. We have the technology to put those on a floor plan, on a 2D floor plan or on a 3D space. As you can see on the floor plan on the right side of the bottom right, you can see where all the fire doors are located. So as we're looking at a life safety drawing, we can see where the fire doors are located. And then when work orders come out for those fire doors, whether you do them quarterly or annually, whatever your frequency is, sometimes you change it to monthly if they're in a high traffic area. Lots of different policies throughout your hospital that you might adhere to. But make sure you have that accurate inventory so you can document and show that you're performing inspections on that equipment. Same with medical devices, especially movable medical devices. How are you ensuring you're getting 100% compliance both on your high risk and on your non-high risk equipment? You need to have 100% compliance on both of those. So how do you identify those assets? We recommend putting a QR code on the asset. Barcodes, you may see some items with barcodes. QR codes, you could do a little bit more with them. You could actually scan it and have it linked directly to a software page that tells you more about that asset, where a barcode is just kind of, you have to use within that device. So, again, start thinking about moving towards the future and moving towards QR codes. I think FSI switched to QR codes for some customers a while back that are just requesting that and using those things. And place all those assets in your CMMS. And if you know the locations, if they're fixed with locations, put those in the CMMS, on your floor plan, or be very detailed in your description of where that asset's located. If it's movable equipment, such as your, infusion pumps or beds or stretchers, anything that's moving around the hospital, do you have an RTLS, a real-time locator software system that lets you know where that asset's located? So again, technology to help you find that equipment versus just, hunting it down. And then can that, as we talk about integrations as well, is that something we could help show where those icons are moving to and what they're showing? So the inventory is, a huge piece of this, having standard names, having standard categories, having standard space designations, again, sets you up for success later down the road for analyzing some of this data. Which leads us to the next slide.
Yeah, and this one's pretty straightforward. Data preparation, now we have space data, we have asset data. Likely if you're tracking things in that CMS, you have labor data, you have, the last time this asset failed and the history of when that asset failed. And so then there's kind of the next step that's not new at all, but it's taking all that data and kind of setting it up in a way that is useful. So this might be useful for something simple like just analytics and visualization and being able to kind of see that, on trend, this particular asset is starting to fail more frequently. Maybe there's some issue with that asset, or, at a particular facility, we're spending way more time doing XYZ than other facilities. But a lot of this just boils down to kind of basic core data engineering things. You're extracting data, transforming it, you're loading it, and you're modeling it some way to be able to do some kind of historical analysis for it. In the past, this was setting you up for business intelligence, for an analyst or a director or a manager to kind of make decisions based on that. But now we've reached a point where once you have these models set up, you can kind of start doing, letting the AI do a little bit more of that analyst work that used to be relegated to humans. We'll get to talking about that in just a little
bit. All right. Next, once you have that asset inventory, you're 100% accurate, which I know all of you are already. How do you maintain that, and how do you manage those assets? So how do you make sure that the people performing, work on those assets have that information in the field, so they don't have to run to their computer or print something off? So using mobile technology, such as iPads or tablets or even smartphones, something that everyone probably has with them at all times. How do you make it easy for them to get that information in the field? What all information are they looking for in the field as well? So, and then how do you look at those assets? So, and how do you manage that data from installation? Are you if you have a new hospital, it's easy. Everything was installed on a particular date. You could probably, front load or do a mass edit to load all the install dates in your system to a certain date. If you have an older facility, that might take a little bit of digging to get all that information loaded and accurate in the system. Again, standardizing those asset categories. You can't stress standardization enough. I probably say that too much. But calling an asset what it is, a free text description. Somebody could put, AHU, somebody could put air handling unit, somebody could put infusion pump, somebody could put pump dash infusion. There's lots of different ways you see that data. So having a standard category where you can do that analysis work and see what the devices are, see what those manufacturer models are, how do you standardize those things as well, so you know exactly what type of equipment is, and if there's something wrong with that equipment or something, a recall or something, how do you get that information as well? Capture some of that asset metadata as equipment gets smarter. Medical devices are getting smarter with software, and which makes them more vulnerable to security attacks. So somebody could actually hack into your medical devices and potentially change the dosage of something if they wanted to. But that extends to the facilities department as well. Think of, somebody hacking into a chiller and shutting that down in the middle of summer. I know many of us are going through a heat wave, but that's a huge risk. So if there are vulnerabilities or software patches that need updated, how do you capture that information? How do you create alerts in your system to know that you have to go ahead and update that? Or how do you know that your chiller company or your medical device company needs to come in and make fixes to that equipment to help prevent that type of information? How do you know there is a vulnerability? So that metadata of software operating system and last updated date and things like that, what version of the software you're on become very important. And then, for planning for future capital replacements, how do you get that data for populating, hey, how much money am I spending on this equipment? So again, as you're managing assets and tracking parts that you're using, tracking labor hours that you're using on that equipment, and then how do you know, is it worth it to keep maintaining that equipment, or is it worth it to buy a new one? I'm sure many of us have been through that in our personal life, particularly with a vehicle. I have an old jalopy vehicle and I'm spending, it's constantly breaking down, it's not reliable. So you make the decision to buy a new one. It's the consequences of your car breaking down are not life-threatening in most cases, but for a medical device, it is. So, if there's a high risk of it breaking down, and you're, doing maintenance on it monthly to keep it up and running, it might be worth it to replace it just to reduce the risk as well. So, how do you feed that data? How do you get that data in there? And how do you, it's a constant update. Every time you're doing work on equipment or an asset, you want to make sure you're capturing that work and that history related to that, so you can do that type of analysis. Finally, we talked a little bit about the maintenance and compliance aspects of it. That's a big reason to have your CMMS, but ensure your ITM program. And ITM stands for Inspection, Testing, and Maintenance. It's actually called out in some of the code language, but make sure you have your plans and they're updated and they reflect the current regulations. As some of you might be aware, if you're a Joint Commission deemed hospital, you know that the standards are changing come the beginning of the year, and we're working with our customers to make sure that's as seamless as possible on the FSI side. But how are you updating your plans? Do you have procedures specifically written to go towards those regulations? Do you have to tweak those as those change? There's been changes in the past where a new regulations like, okay, we're going to change the standard where we're going to relax the frequency on some inspections. So maybe you would do them quarterly instead of semi-annually instead of quarterly. I think that was on some of the fire testing devices, probably, I'm going to say close to 10 years ago now. It might be a little bit sooner than that, but I do remember one of the EPs changing for the Joint Commission that changed that. So you're keeping up to date with all that. Do you have that person on your side in your hospital that knows that those things are changing? How can technology understand those changes and recommend changes to you as well? So, but again, knowing the regulations, knowing if you're switching regulatory bodies, there's a lot of people switch from Joint Commission to DNV, or they might try adopting a new one that's CIHQ or ACHC, one of those regulatory bodies. We don't care. We support them all, but it's, there might be differences in those. And how are you making sure your plans are updated for those things? As devices get newer, are you running an old maintenance procedure on a brand new ice machine that maybe you need to do something a little bit different to help prevent, the spread of Legionella or something along those lines? Is there something new or something, that you might be able to do less frequently? Maybe there's a new chemical that you could run through it or something. That's a fictitious example, by the way. So don't just assume that exists. But are you standardizing those as well? Notice that word standardization comes in. Do you have your maintenance programs aligned to the regulations? Do you have your procedures across all your business units? Are you doing the same inspection on certain types of devices through all of your hospitals. If you're an enterprise system, it makes it easy to compare hospital A to hospital B. But what if hospital A is in the north and hospital B is in the south? Are there different, keep in mind location of that and climate. The chiller filling in Montana might not have a big of a risk of a chiller filling in Florida, here where I'm at right now. So again, think about risk and think about those types of things as you're setting up these ITMs. So there, as much as you want to standardize, I'm just saying you can't necessarily standardize everything. There might be some variances you have to keep in it, but do the best you can as well. But your inspection checklist, how you're reporting on the results and how you're performing corrective maintenance. If there's a failure, are you documenting what you did to correct that failure? That's one of the most common findings is if a medical device fails and then you fix it and you don't document the retest, that's one of the biggest findings, according to one of the regulatory agencies that I was talking to. Again, not documenting your retest or not documenting what you're doing to correct those failures is something they ding you on. We'll use a technical term. I think that's right in the manual. They ding you on that one. And then how are you reporting those in your CMMS? Do you have a dashboard that lets you know how you're doing? Do you have procedures that let you pass or fail certain types of devices and then generate those failures automatically? Take advantage of the technologies in your CMMS to make those things happen for you. So that leads us to the future, and I'll pass this on to Justin here to sort of walk us through a brief what's upcoming, and we'll go through each one individually. So
cool. And yeah, we call this future evolution, but like I mentioned earlier, there's a lot of places in building out those pillars where things like AI can make it easier to get you to that kind of like ready state. For example, when we're talking about managing inventory and getting assets into a system or identifying where they're located or anything like that, there are things like image recognition for actually uptaking assets. So when you're taking those panoramic scans of your facility, there's a lot of fairly stable algorithms that can say, oh, there is a, that's a boiler in that image, and then have it ready for someone to, say confirm that's correct, it's in that location, and then based on image data, we can say, we know it's exactly right there, and then it's just, tagging it so that it's got that QR code we mentioned. There's things like anomaly detection, which, if you set up, an Internet of Things style system, or you have a bunch of assets that can kind of communicate with each other on a network, then you might have something that can say, hey, this part of this building is actually, getting warmer than it typically does. And yes, it's warm outside, but it's too warm for how warm it is outside. And that's an anomaly. And maybe that means that something's wrong in this wing. And that can kind of, take away some of those pieces that may be missed, or the pieces that may be more tedious in kind of managing those. There's also, AI can help make your data more accessible. So there's parts of that, like we mentioned earlier, like building out models for things like analytics. Maybe you don't necessarily need a full report built. AI can help you kind of access that data and access those models without needing to, learn SQL or like Postgres or any of these kind of database engines, because it can help you query that data for a quick answer. Sometimes you will still need the more advanced stuff, but sometimes you don't. Sometimes you just need a quick answer, and AI can kind of help with that. It can also help you streamline operations and productivity. So, you might, like the, example Joe mentioned, you might have a really dense manual that's 75 pages long that, has some procedures and typical, maintenance in it. And it might take a technician, 10 minutes to skim through that and get to the part they need and get the data out that they're looking for. Or if you have these things kind of digitally stored, then you might have a kind of, manual reading agent that can then parse through that, summarize it, or maybe if you want to be certain that the summary is not missing anything, it can search through that manual and tell you, hey, you need to look on page 65, 3/4 of the way down the page. This is where maintenance instructions are. And then lastly, stronger data, more ways to use it. So AI can help you do things like make sure that the compliance code book that you're operating on, for example, is accurate. So the data that you're powering your system on is up to date because you have an agent that is monitoring code changes online. And when those change, it can, notify you in some way that this code changed, this is how it changed, these are the procedures that are likely impacted by this code change. And again, all of this becomes possible because we have an environment that is so connected, and we have these pillars that all of this is built on that we mentioned previously. And also, like Joe mentioned, he mentioned that in some cases it's difficult to standardize data. That's another kind of point where you might leverage something like a basic AI mapping agent. Maybe you have data that you're migrating over and a lot of things aren't categorized in a certain, maybe for some reason you don't have assets categorized or something similar. But you have descriptions of assets, you have asset numbers, and you have an agent that's been kind of pre-trained on what an asset is and how it's used. And based on that information, instead of going through and having to tag 2,000 assets, an agent can take a first pass, and then you only have to confirm. It's much quicker. Again, just kind of making sure that it's easier to keep that data verifiable and consistent. And we can go into a few more details on these, but that's kind of the high level overview of some of these use cases that we're going to talk about.
All right, so we'll start with the asset inventory, as I call it, the other AI, and some things that can help you do the inventory. One is image recognition, and image recognition is basically with massive data sets of images containing biomedical and facilities equipment. If you take a picture or scan or take a photo, it can help identify what that equipment is. I picked these two because they're kind of similar looking if you look at them. A chiller and an MRI machine. They're both tubular and they're both in hospitals. So that's probably where the similarities end. They do different things completely. But as those algorithms are trained, and they get better and better as the day goes on, the more we use them, the better they get at understanding what these are. But they can see what the complex patterns are within the image and help identify what type of device that is. And basically, when it gets a new image, it looks at the image. It says, "What is this? What does it look like to me?" You could also look at taking a picture of the nameplate information. That might help identify that as well. So what are some things you can do to help identify what that equipment is? And then once it processes that image and goes through that picture, it kind of uses the object detection where it identifies the type of equipment, but also highlights the position within the image. So if it's tied to a space or tied to a floor plan, think of that first pillar when Justin showed the scans of the rooms. If we did that scan in a mechanical room or in an MRI room, can it locate that equipment right in that space based on where it matches those images? So if I'm taking an image and I do that scan and or does it do it right from those scans? Like it knows exactly where it is as I'm performing that scan. So that Google car that's driving through your hospital, or it's not a Google car, but is that adding these to the inventory? Do I need to get closer to the nameplates to get that information? What do I need to do to make it useful and gather that accurate inventory of equipment? Keep in mind, some equipment might be shoved in a corner, the nameplates might not be available, there might be 4 or 5 of them put together or really close together. So there's still lots of work for this to be perfect, but is it an assistant for a human going through and doing this type of inventory? Can it solve 80% of the problem of getting an accurate inventory, and now that person needs to really focus on 20%? Again, where does it save time? That's sort of the biggest thing, the biggest saver of where technology can help. So. Justin?
Yeah, and I'll start moving kind of quick. I do recognize we're a bit short on time, but when I'm talking about accessible data here, what we're talking about is, right now, if you have a data engineering team or an IT team with, Power BI or Tableau experience, or you're using software with built-in dashboards, then a lot of times you can get answers to data, answers about your data very quickly. But there are always going to be scenarios where you have a question about data and either it's not possible or it's very tedious through whatever reporting setup you have to get that insight. And this is another kind of scenario where AI can just kind of be an assistant for you that allows you to kind of get the answers that you're looking for without needing to go take a SQL course or a Power BI course in order to visualize that data. The example that I'm showing here is a tool that we're working on right now to actually to augment FSI's CMMS system. And you could kind of see here that I'm just asking it, can you tell me which assignments currently have the most open work orders? And in this case, it included assignments that say none. but it gives me an immediate breakdown of, there's this many work orders open, most of them are none, but some of, this Isabella Crown person has 69 work orders open and John Anderson has 31, and then it'll give you some basic visuals to kind of show that. You can pin those and kind of use those to build out your own kind of rudimentary dashboard. And the kind of key thing there is that if I'm a director that's just not a technical person at all, or I know how to maintain an anesthesia machine, but I don't know much about software, then I don't need to go learn these things in order to ask questions about this data. And so you may be asking about things like, how's my work distributed? What upcoming work orders are there? What work orders are in my queue? What assets do I need to, where are most of the assets that I'm going to work on today located? All of these things that someone can build you a dashboard for, but in the meantime, while you wait on that dashboard, you can just ask an agent and it will give you that kind of response back, the key insights back on that. And then when we're talking about streamlined operations and productivity, I just want to show this example again. So, one thing that these LLMs are very, very good at is digesting unstructured information. So the example I'm showing here is a manual for an infusion pump where there's a lot of text and, you're trying to get to just the information you need in order to complete a work order or complete, whatever ITM you're doing. There are other scenarios where you might have an image and maybe you want to say, you just want to quickly categorize the visual state of a machine in a boiler room, and you can take an image of it, and that whatever image recognition model is looking at that is trained to be able to look at that and say, hey, there's denting here, there's cosmetic defects here, but there's actual structural issues here. But in the example I'm showing on the slide, we have a manual, and then the result of an AI. This was a real example that I did where I kind of found a manual online, copied a bunch of information from it, ran it through one of our summarization models, and the output is, this procedure, power off, disconnect, and then it gives you a brief summary. And you might, build these directly into an application if you have an iPad, and it just shows that as the procedure to a technician. And if they need more details, maybe also links to the manual that comes from.
Dang, you should try it with an IKEA manual and see what happens. There's no words on those ones. Going back into compliance, I pulled the big players in compliance agency, the DNV and Joint Commission. But how can you use AI AI tools to track regulatory changes in real time? Can that AI agent be monitoring those documents for changes and guidelines from various sources? Can they alert you if there's a change in what those things are? So how does it alert you, and how does it be more proactive in helping you prevent and avoid failures based on you not knowing that one of those updates happened? So again, with continuous monitoring, how can you, again, save yourself time by not having to read a blog or an ASHI update or something, or something from the regulatory agencies to understand what all that is. And then finally, how could you use natural language reporting, what Justin just showed a slide or two ago on, think about doing that for, again, show me all my high-risk equipment compliance, or show me all my unable to locate, and what I did to follow up on those types of things. So as you're looking at different pieces of information, if you're not familiar with the data and knowing what all the nuances of your own data are, if the data is standard and it's consistent, natural language can help find that information. Like I said, for an on-demand report during document review, if you're generating a hospital policy, or if you're just doing your monthly reports, again, this can really help you save time in preparing your compliance documentation. There's probably a future where nothing's prepared. You just, let the regulatory agent ask the questions to your own AI. But what do you want to see? And it'll show it to you. So, but that's sort of where we're going with all this. If everything's linked together, we could use the tools to help us out with those.
And then the last thing that we'll kind of cover here is, a lot of the things that we've talked about so far in terms of asset capture, building captures, and monitoring your facilities still rely on a lot of, moving around, a lot of, human-esque work. And surprisingly, we're pretty far along in the realm of robotics, especially when you start to pair robotics with AI. And we're not talking, you see these kind of Boston Dynamics humanoid robots doing dances and everything, but really robots do not need to be that advanced. in order to help you get a lot of these things done. So the image that I've shown here are actual, proof of concept things where we've designed basic robots that can move around. They have sensors. They might be measuring air quality and temperature and Wi-Fi, or they might have cameras and maybe they're scanning rooms. Maybe they're moving things around. And a lot of the components that go into these bots, yes, they take a little bit of engineering to design, but you can build one of these bots for sub $500. In the top right, that's a real example of a robot where all the parts together combined in that are now cheap enough to be able to build something that can go around your facility and monitor it for under 500 bucks. And so you can imagine something that is maybe, going around doing periodic scans and notifying you whenever, something seems out of place or something seems broken. Maybe it's doing visual condition assessments around your facilities, or, it's noticing that, hey, this door looks new. I don't recognize this. It seems like this fire door has been replaced and it wasn't updated in the system, or what have you. And then there's a real image on the right of the kind of machine that we move around with when we're scanning facilities to generate those kind of digital twins at the bottom right. But there's a lot of different ways that you can use robots to also help automate some of the more physical components of making sure that you're compliant and that you understand your facilities. And I figured we might be running out of time getting here, so I did link on the last slide. We've recently did a big talk on kind of more on how those robots have become so much cheaper and how much kind of ROI you can get on looking into and investing in robotics, especially when combining it with AI. And I've linked that here. It's from Health Spaces if you want to look it up. It's led by the CEO of Enstoa, Jordan Cram. But I know we are, I think, out of time.
Yeah. So yeah, we're at the Q&A portion of the item. So submit your questions and we'll see what the questions are and answer them.
Okay, great. We've actually got quite a lot, so I'll get through as many as time allows. Otherwise, I'll send you the other questions afterwards, and you can answer them at your own convenience. Okay, the first question is, what kind of role could AI play throughout regulatory compliance or audit readiness processes?
Yeah, I mean, that's, things that we've mentioned before. So there's everything from condition monitoring. So you might have something that's using, either sensor data or images to kind of identify the current state and maybe risk of a particular asset. You may have something that's helping you ingest data and kind of, map data to make sure that you are, again, keeping the kind of electronic state of your system consistent. You might be doing things with predictive maintenance to kind of estimate the remaining useful life of assets based on, how well they perform their tasks currently, combined with how old they are and what manufacturer they came from, and et cetera, et cetera. You might be automating workflows. There's a lot of different potential ways that the kind of new generative AI can help with implementing an AEM program. And Joe, if you want to add on that.
Yeah, a lot of those become part of your building automation systems for failures or your medical equipment. If there's characteristics that indicate a failure is about to occur, if you can catch that before it occurs versus after it occurs, the cost of fixing it before is way less than the cost and consequences of trying to fix it in an emergency situation. So a lot of it is around the a reliability center maintenance program or a predictive maintenance program or condition-based maintenance program. But what are some things that are letting you know that something is about to fail? So.
Okay, so what kind of training or change management is required for technicians and managers for implementing AI usage?
So that's a good one. A lot of that depends on how you want to use things. In a lot of cases, a lot of the pre-trained models that exist now are good enough to accomplish these use cases where, if you're just trying to automate something like, for example, if someone sets up an agent, like I mentioned earlier, then in terms of accessing data and querying data, then it's helpful to know kind of how to prompt those things. So there are times where you might ask AI a question and it gives you a response. And like if I say, what all work orders do I have that are open right now? It may, by default, generate a query that is querying for work orders assigned to me. And maybe I'm a manager and that's not, valid. And so being able to identify kind of when those kind of mistakes or those kind of misunderstandings between you and the agent you're trying to interact with are happening, and how to, reprompt it and say, no, I don't mean assigned to me. I mean, work orders to assign to people that are on my team. So there's prompt training. There's also just general data, understanding like what is good data, when I'm tracking data, why is it important, and how do I make sure that the data I have is consistent. That kind of training can be very helpful, and just general kind of understanding of what a holistic data system is and what it means to have all this data connected, and how I can make sure that I'm not creating silos or redundant data, and I'm entering data into my source of truth. I'd say those are the kind of big things from a data engineering standpoint. Joe, if you want to comment on the kind of.
No, I think you covered everything on that one. So we'll move on to the next question.
Okay, so what operational area do you see benefiting the most from the introduction of additional tech tools?
It's hard for me to imagine an area that's not going to look totally different from the implementation of these over the next 5 years. To be honest, it's hard to answer that. I'd say operations will see a lot of things that become much smoother, a lot less just digging and searching for things, a lot less needing to log into a system, check something, log into another system, check something, and more having a chat GPT style agent on an iPad as a part of your CMMS app, where you can say, hey, I can voice Siri, where is this asset located? I need to inspect it, or help me understand better how to complete this thing that I'm assigned, or et cetera. But it really will, I think, touch every aspect of healthcare.
And a key to that's going to be the integration setup and making sure the systems are talking to each other. Because as much as we tried, there's not one system that does everything. There is information coming from multiple sources. So that's something you definitely want to be mindful of as you're preparing for this. And it's only going to get better at doing it as time goes on. So it's already pretty good now, but like I said, it's getting the information from multiple sources is going to be one of the challenges, I'd say.
Yeah, and there's even companies that are doing things like when renovations are happening or new builds are happening, in a hospital or otherwise, there's whole algorithms and software is built out now where as that construction or renovation is happening, you take pictures with your phone, or like some phones have basic LiDAR built in, but you can take images, or if you have a LiDAR scanner, you can track the progress of that build and compare it to what is designed, so you can plan for how that as-built's going to differ from the actual design itself, or identify where the build's not going to plan and where there might be issues. So everywhere from like when you're building the hospital to the ongoing maintenance of the hospital is kind of impacted. So.
Okay, this one's for Joe. Does the FSI CMS contain the AI tools to monitor CMS, TJC, TMV regulations and standards? If yes, how are updates communicated to users?
All right, so we're not doing that with AI right now. We're still doing that manually, especially with the new changes coming into place. There's no models trained on the mapping of to the new Joint Commission standards. So it is something we're loading into our system as part of the second half of this year for our product team and engineering teams and implementation teams. Frankly, a lot of our teams at FSI, we're loading those in, and we're changing how we store and update the standards to make it more universal across our entire customer base. And again, we call it standardizing the standards on our side, but that's what we're doing to prepare for ourselves for what AI can do to help communicate those items. There is some debate on whether or not we make changes automatically or just recommend changes to customers. We don't want to be tweaking some things. There might be other authorities having jurisdiction. So we're being mindful of what AI can do, and also being mindful of any restrictions we have from hospital IT departments on using AI. So there's something there as well. But again, manual for now, but we're setting the stage for AI to help us with that. That's going to be a huge time saver on our part as well. And again, making all of our customers see the same standards across all of them, whether you're Joint Commission or DNV or one of the other ones. It's going to be the same look and feel of those standards across the organization. And we're also looking at expanding that into different types of facilities. As we look at the standards for a hospital, how they differ from a long-term care facility, how do we have all those in place as well? So.
Okay, so on the topic of change management, how much resistance, if any, have you seen from the more seasoned facilities staff when it comes to utilising AI solutions?
It's very hit or miss for, in a lot of cases, there's resistance up front of people kind of assuming that things won't work or just kind of being resistant to the idea of AI. There's this notion that it's gonna, kill a lot of the jobs or something similar. But in a lot of cases, once people start using it, they start to realize that like, oh, I don't need to, make 15 clicks to go into this report and drill down into this drop down in order to ask a question. I can just ask this. A lot of times, once the use is there, then the adoption, the kind of satisfaction kind of comes very quickly afterwards. But especially with things like the facility scanning and the object recognition, like being able to tag assets semi-automatically, I don't know that we've seen a ton of resistance from that, just because it it makes a very tedious task much less tedious a lot of the times, and it's kind of hard to resist that.
Yeah, and from what I've seen it all over the place. I've seen customers, still using paper systems to some, really using Power BI and doing analytics on their end. So there's a wide range of technical barriers within different departments that we've seen. I'll say, very small percentage at that level that's already utilizing it successfully. So.
Perfect. Okay, time for one more question. I think with AI, are your thoughts to create a list of potential questions that may be asked to limit data released?
Can you repeat that question?
Yeah, I missed something there.
Yeah, hang on. With AI, are your thoughts to create a list of potential questions that may be asked to limit data released?
So in some of the approaches that we've taken, so like, again, going back to that kind of data accessibility answer, we don't actually, we do some kind of, parse, like filtering and just cleaning of inputs to make sure that people aren't trying to, when people talk about jailbreaking AIs and getting them to, answer in ways that they're not supposed to answer, we do some kind of cleaning to make sure things like that don't happen. But we actually take an approach where we set these agents on top of an environment, and that environment is kind of a curated view of the data that we say, to the AI, only these, five things exist. Like the AI can't query a system that it doesn't have access to. These aren't like Skynet type tools. They're, statistical things that know how to query a model that we built. And so you might have a fully in-depth model that has a lot of information or, complexities that you don't want it to have access to. And it's pretty straightforward to limit it to say that, this agent here is only for querying asset performance data, and it only has access to these 4 tables. If someone asks a question about, like human resource information, the AI might try to run a query against the model, but it's not going to return any data because there's no data in the model that the AI has access to. So it's pretty straightforward to kind of quarantine it to, only a space that you want it to have access to.
Perfect. Well, we're coming up to our hour. So thank you both, Joe and Justin, for, of course, another great and informative presentation. I'd like to encourage everyone to visit FSI's website to learn more about the services and products they provide for the industry. So please visit fsiservices.com. As promised, the answer to today's trivia question, of course, is Georgia. So congratulations to our winner, Sang McFarlane in Utah. Just a quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Also, I just want to mention that here at TechNation, we're always looking for ways to improve our webinar series. So Webinar Wednesday wants to hear from you. Included in the follow-up email will be an extra survey link, which we would appreciate you taking the time to complete so you can help us bring the content you want to the Webinar Wednesday series. As an incentive, if you submit your answers by August the 22nd, you'll have the chance to be entered in a draw for a $100 Amazon gift card. Now, if you've missed any of our past webinars, including any by FSI, please visit webinarwednesday.live to view our whole webinar archive. We'll be back next week with another webinar. So again, visit webinarwednesday.live for more details and complimentary registration. So thank you once again for your time today, and I hope you enjoy the rest of your day.